Okay, guys, it's lab time. Let's go for the record. A gold record, that is, because everything Mr. Bayona does is fire. All right, we're learning about circles, so what better thing than a gold record, right? Okay, the gold record's really cool because we can use it to understand a couple things about rotation. Okay, so first off, we've heard the word rotation and we've heard the word revolution before. Like, I'm gonna start the revolution, right? But that's not what revolution means in the realm of physics, all right? A revolution means you got this thing called an axis, okay? A pivot point. If the axis is outside of your body, like this, outside your body, and you move around that central axis, move around that central pivot point, that's called a revolution. This is like the Earth and the sun, okay? The Earth goes around the sun, that's called a revolution. How long does it take for the Earth to revolve around the sun? All right, we've heard that before. On the other hand, if my axis of rotation is inside my body, this is called a rotation. This is called a rotation. What you're going to be doing today in your lab is you and three of your friends, three of the people I put you in a group with, are going to square dance. You're going to link arms together, and you're going to move. You're going to cycle. But now it's up to you to decide whether or not the axis of rotation is inside your body or outside your body, all right? So you're moving today in what we call a rigid body. Notice this record, it doesn't have any parts that move slower than any of the other parts, right? They're all moving at the same time. Watch this. So here are you and your three friends. I'm going to go 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000. Notice that even though I'm further out, I have a greater radius as I move this way, right? I have a greater radius. This radius is not as big as the radius of the second guy, not as big as the radius of the third guy. Notice no matter how far out I am, the frequency took me, let's not do frequency, let's do the period. How long did it take? What was the time it took me to do the cycles, all right? To do the cycle, all right. So it did 4 seconds to do one cycle, right? So this is my frequency, or it's my period. My frequency is, we know this is just the cycles, how often this occurred, right? The cycles in the time period. Notice how these are just basically flipped. So all I got to do to figure out the frequency is flip this number. And I get 1 over 4. This is, I get a quarter of a turn every second. We call that hertz, okay? It's measured in hertz, frequency measured in hertz. Period is measured in seconds, so it's about 4 seconds per cycle. 4 seconds to complete a cycle. Okay? So you notice that in rigid body motion, everything is stuck together, that no matter what part of the circle I am, the rotational speed is the same. See? The rotational speed is the same. We all have the same rotational speed. All right? So 0.25 turns per second, 1, 1,000, 2, 1,000, 3, 1,000, 4. All right? So we all have the same rotational speed. This has a couple of effects. If you look very carefully, what do you notice about these smiley faces? Which one of these looks like it's moving the slowest? Which one looks like it has to move the fastest to keep up? All right, so keep that in mind. My frequency is the same for all of them because it takes them the same amount of time to finish rotating. My period is the same for all of them because they can't move ahead of each other. They're all stuck together, moving as a rigid body. Okay? So if my rotational speed is the same, my rotational speed, my rounds per minute, my cycles per second, RPMs, right? So this is the same for all things in a rigid body. What's going to be different is my linear or my tangential velocity, okay? And this is why. We know that velocity is distance over time, right? So since we're going in a circle, the distance is the circumference. And the time is going to be the period, okay, the period. Okay? Circumference is 2 pi r, right? We know that from geometry. Get 2 pi r over the time period. That's how we get our velocity centripetal, okay? Velocity in a circle. Now watch why my outer guy looks like he's going to be going a lot faster. Okay, watch. What's the amount of distance that my inner guy has to go? It's a little circle, right? A little teeny circle. Well, watch what happens the further and further I get out. That's a bigger circle. So look what happens. Bigger circumference over a smaller period of time. It's a bigger centripetal velocity or tangential velocity. Okay, last one, check this out. Bam. Okay. So if I were to cut away this record right now, even though they're all moving at the same frequency and have the exact same period, look at my velocity vectors, my tangential velocity vectors. And look at my tangential velocity vector. Bam, this would break off in a straight line, or tangent. This would break off in another tangent, but look, it would obviously have to go a lot faster, right? Okay, and the outer one would have to go the fastest in a tangent to the circle. All right, so keep these things in mind as we do the lab today.